Hello and welcome to Limitless Math, your guide to mastering mathematics. Today, we're diving into a fundamental skill in algebra. We're going to learn how to simplify any algebraic expression step by step. This is a key topic for high school and college students, and it's essential for exam prep like the SAT, AICT, and AP Calculus. By the end of this video, you will be able to, first, identify like terms in an expression. Second, combine like terms to simplify. And third, use the distributive property and the order of operations to solve more complex problems. Don't let these terms intimidate you. We'll break down everything with clear, guided examples. Let's get started with our first problem. For our first example, let's start with a simple expression. Consider the expression 4x plus 3 plus 2x plus 5. Our goal here is to combine everything we possibly can to make this expression as compact as possible. The first step is to identify what we call like terms. Like terms have the same variable raised to the same power. They are terms that we can add or subtract together. Looking at our expression, we have two terms with x. That's 4x and positive 2x. Notice the plus sign in front of the 2x. That's part of the term. We also have two terms that are just numbers. These are called constants, positive 3 and positive 5. Now that we've identified our like terms, the next step is to combine them. Let's start with our x terms. We have 4x and 2x. Adding them together, we get 6. It's like saying you have 4 apples and then get 2 more apples. You have a total of 6 apples. Next, let's combine our constants. We have positive 3 and positive 5. Their sum is 8. Now we write our simplified expression by putting the combined terms back together. We have 6x from our first group and 8 from our second group, so our final answer is 6x plus 8. And there you have it. We took a longer expression and simplified it into a shorter equivalent one. This is the core idea behind simplifying algebraic expressions. That first example gave us a solid foundation. Now let's tackle an expression with a bit more complexity. Our second problem is 3 times the quantity x minus 2 plus 4. You might be thinking, what's the 3 doing out front? This introduces a new concept. It's called the distributive property. It tells us that the number outside the parentheses must be multiplied by every single term inside. So here, the 3 needs to be multiplied by x, and it also needs to be multiplied by negative 2. This is a very common mistake to watch out for. Ensure you distribute to all terms inside. Let's perform that multiplication. 3 times x is 3x, and 3 times negative 2 is negative 6. Now our expression looks much more familiar. It's similar to our first problem. The next step, just like before, is to combine our like terms. This time, we only have one x term, so we'll leave that one as is. But we do have two constant terms to combine. We have negative 6 and positive 4. When we add them together, we get negative 2. Putting it all back together, our simplified expression is 3x minus 2. Great job. Remember, when you see parentheses with a number next to them, think distributive property. It's your first key to unlocking the expression and getting to a point where you can combine like terms. Let's level up again with a challenging multi-step problem. This one will bring together everything we've learned so far. Here's the expression, 4x plus 3 times the quantity x minus 5 plus 6. When faced with an expression like this, the first thing to remember is the order of operations, often remembered by the acronym PEMDAS. PEMDAS stands for parentheses, exponents, multiplication and division, and finally, addition and subtraction. We always work in this order. Notice that multiplication comes before addition. In our expression, we have a term with parentheses, 3 times x minus 5. To solve this, we must first use the distributive property. This means we multiply the 3 by everything inside. 3 times x is 3x, and 3 times negative 5 is negative 15. So the parenthetical term becomes 3x minus 15. A common mistake here is to try and add 4x and 3 first. Remember, multiplication, or in this case, distributing, has a higher priority than addition. So we must distribute first. Now our expression is 4x plus 3x minus 15 plus 6. This is a form we know how to simplify. We'll identify our like terms. We have 2 x terms and 2 constants. The x terms are 4x and 3x. The constants are negative 15 and 6. Combining the x terms, 4x plus 3x equals 7x. Combining the constants, negative 15 plus 6 equals negative 9. So our final simplified answer is 7x minus 9. This problem highlights the critical importance of following the order of operations. Always distribute before you add or subtract. Now for our final example, let's look at how simplifying expressions applies to a real-world problem. This one comes from geometry. Imagine we have a rectangle. We don't know the exact measurements, but the length is described as 3 more than twice the width. We can write this as length L equals 2w plus 3. The problem is to find a simplified expression for the perimeter of this rectangle. First, we need to recall the formula for the perimeter of a rectangle. The perimeter P is found by adding up all the side lengths, which simplifies to 2 times the width plus 2 times the length. Now we can substitute the expression for the length into this formula. Remember, we were told L equals 2w plus 3. So in our formula, we replace L with the entire expression 2w plus 3. Look at what we have now. It's an algebraic expression just like the ones we've been working on. Our task is to simplify it. Following our order of operations, the first thing to do is distribute the 2 into the parentheses. 2 times 2w gives us 4w, and 2 times 3 gives us 6. Our expression is now 2w plus 4w plus 6. The final step is to combine our like terms. We have 2 terms with w and 1 constant. Adding the w terms together, 2w plus 4w is 6w. The constant term is just 6. So our simplified expression for the perimeter is 6w plus 6. This means if we knew the value of the width, w, we could just plug it into this simple expression to find the rectangle's perimeter. It's a powerful demonstration of why simplifying is so useful. Let's quickly recap the powerful steps we've learned for simplifying algebraic expressions. We learned that the key to simplifying is combining terms that are alike. The main steps are, first, use the distributive property to eliminate parentheses. Second, combine any like terms by adding or subtracting them. And always follow the order of operations or PEMDAS. By following these steps, you can take any complex-looking expression and transform it into its simplest, most manageable form. This skill is the foundation for solving equations and tackling more advanced algebra and calculus concepts. I hope this step-by-step guide from Limitless Math was helpful for your math help journey. If you found this video useful, please give it a thumbs up, leave a comment with your questions, and subscribe for more step-by-step solutions and exam prep tips. Keep practicing, and remember, with Limitless Math, your potential is limitless. See you next time.